It began as a data anomaly, a faint streak detected by ATLAS on October 16, 2025, initially dismissed as calibration noise. When the follow-up frames arrived, the signal persisted, a diffuse plume extending roughly 6,000 kilometers from a nucleus no larger than a mountain, oriented not away from the sun, as radiation pressure models demand, but directly toward it. Cross-verification followed within hours. Observatories in Chile, Hawaii, and the Canary Islands confirmed identical geometry. The sunward bias was real. The initial assumption was instrumental error, perhaps a misalignment of the CCD array or a pointing drift. None were found. The reduction pipelines were clean. The comet was behaving in a way that contradicted both thermodynamic expectation and photometric precedent. Designated 3I Atlas, it became only the third confirmed interstellar object in recorded history. The orbit was shallow, the eccentricity greater than 1, the inbound velocity consistent with capture from the local galactic field. Spectroscopy returned an equally irregular composition. Strong nickel lines with iron below detection thresholds. Carbon dioxide dominating water by nearly an order of magnitude. Trace cyanide present, but spatially decoupled from metallic emission regions. No known comet in the solar system shares these proportions. The photometric light curve revealed periodic modulation every 4.02 hours, stable across multiple observation windows, consistent with slow axial rotation or organized venting cycles. The brightness variations followed a predictable waveform: rise, plateau, decay, repeating with mechanical precision. The combined anomalies resisted standard modeling. Outgassing from volatile ices could not produce sustained sunward flow at the observed heliocentric distance. Radiation-driven jets require anti-solar orientation. Magnetic coupling was considered but unsupported by local field data. No plausible natural mechanism accounts for the geometry. The working hypothesis shifted toward complex topography. A non-spherical nucleus with concave depressions focusing emission toward the star. It fits some of the observations but not the persistence or symmetry. By late October, the object had become a priority target for every major facility capable of narrow-band imaging. Data flowed continuously, each set deepening rather than resolving the puzzle. A comet exhibiting reversed activity, anomalous chemistry, and rhythmic luminosity implies either a formation environment radically unlike the solar system or an internal structure that behaves as if engineered. Both possibilities remain speculative. What is certain is the absence of noise in the measurements. Multiple independent teams, multiple instruments, same conclusion. The emission points toward the sun. The chemistry is wrong. The rhythm is real. In November, ESA's Hera and NASA's Europa Clipper will transit near its projected path. Their spectrometers may confirm or contradict the ground-based data. Until then, interpretation remains suspended between physics and possibility. There is no theory that predicts this behavior, only a growing archive of consistent observations and one unavoidable fact. 3I Atlas does not act like anything we have seen before. Chapter 1. The Visitor That Shouldn't Exist. October 16th, 2025. The detection appeared at 0243 UTC in data from the Asteroid Terrestrial Impact Last Alert System, ATLAS, operating on the Haleakala Ridge. The initial automated classification listed it as a faint near-Sun comet, magnitude 17.3, elongation 14 degrees. The tail vector, however, pointed directly toward the solar disk. The pipeline flagged the geometry as invalid and marked the record for human review. At first, no one noticed. By midday, a researcher checking daily anomalies reran the photometric centroid fit and confirmed that the direction was not an artifact. The feature persisted across multiple exposures and calibration frames. Within hours, the target was re-imaged by auxiliary telescopes in Chile and the Canary Islands. Every image returned the same impossible alignment. The emission flowed toward the star that was heating it. The event entered the Minor Planet Center feed as Provisional C2025A3, ATLAS. 48 hours later, Orbital Solutions ruled out a bound origin. Its hyperbolic excess velocity exceeded 25 km/s1, confirming interstellar provenance. It became 3I Atlas, the third confirmed interstellar visitor after 1I Oumuamua and 2I Borisov. From that point, the anomaly hardened into fact. Spectroscopic measurements from the Very Large Telescope and the NASA Infrared Telescope Facility recorded emission bands inconsistent with ordinary cometary spectra. The nickel doublet at 341 Nelma was prominent. Iron lines that normally accompany it were absent. The CO2 to H2O ratio exceeded 8:1, a composition unseen in any body formed inside the frost line of a planetary system. Photometry over a 9-day baseline revealed a periodic modulation of 4.02 hours, too regular for stochastic outgassing, too slow for rapid tumbling, too stable for fragmentation. The light curve's symmetry implied a repeating surface process, perhaps a venting cycle, or an exposed rotating facet. Models attempting to reproduce the observation failed unless they invoked emission jets oriented sunward, maintained by an internal energy source, or by geometry no comet nucleus should possess. Each new dataset deepened the contradiction. Radiation pressure cannot drive dust and gas toward the sun. Sublimation forces oppose heat, not follow it. The solar wind's magnetic component is orders of magnitude too weak to channel jets at that distance. Collimated flow requires confinement, yet no confinement mechanism fits the thermal regime of a volatile rich body. Some proposed a concave depression acting as a parabolic nozzle, reflecting sunlight inward, but the persistence of the effect across varying heliocentric angles argues against a purely geometric cause. Others suggested electrostatic coupling between metallic grains and the interplanetary field, but charge densities required would disrupt the nucleus entirely. Every physical explanation strained credibility. By late October, 3I Atlas had moved within 0.45 AU of the Sun. Instruments from the Solar and Heliospheric Observatory recorded a compact coma with unexpectedly low polarization. Another anomaly indicating fine, possibly metallic dust. A joint analysis by ESA and NASA teams produced a composite albedo map showing reflective regions alternating with matte zones in a periodic pattern matching the photometric rhythm. The coincidence between surface patterning and the 4-hour pulse raised an uncomfortable possibility. The modulation was not random evolution, but controlled emission, energy cycling through discrete states. No one suggested intention, yet the data carried that implication in silence. In the control rooms, the conversation shifted from verification to containment. Could an interstellar object carry internal magnetic domains capable of responding coherently to solar radiation? Could nickel-carbon lattices undergo phase transitions that mimic propulsion? Theories multiplied. None matched observation in all parameters. The phenomenon became a test case for the limits of cometary physics. Papers circulated in preprint servers under cautious titles: Sunward Emission in Hyperbolic Bodies, Photometric Modulation in 3I, Atlas, Possible Non-Gravitational Forces. Each ended with the same admission: insufficient data, unresolved mechanism. 2 spacecraft were already in flight that might pass through the object's influence zone. ESA's Hera mission, en route to the Didymos system, and NASA's Europa Clipper, outbound for Jupiter. Both carried high-resolution spectrometers sensitive to the relevant wavelengths. Adjusting trajectory for a fly-through was impossible, but side-lobe instruments could still register trace emissions as the paths intersected near November 1st and 6th. Coordination teams planned simultaneous observations, hoping for corroboration or contradiction. If Hera detected enhanced nickel signatures, the anomaly would harden into a new category of celestial behavior. If nothing appeared, it would fade into the catalog as another unsolved transient. Either outcome would be data. Meanwhile, the comet's brightness curve flattened, its jets stable, its rotation unaltered. Nothing exploded, nothing dispersed. It behaved as if equilibrium had been reached in defiance of the energy it received. The term reversed comet entered internal notes. Some called it a mirror comet, others an attractor, none officially. The International Astronomical Union refrained from commentary. In scientific writing, silence can be a form of restraint. The question that remained was not why the tail pointed sunward, but how many such visitors had gone unnoticed before detectors improved. Every advance in instrumentation exposes new categories of outliers. Each outlier forces revision of what counts as natural. 3I Atlas occupies that boundary, neither dismissed nor understood. It may represent a chemical lineage alien to our solar formation, or it may reveal gaps in the thermodynamics we thought complete. As the object approaches perihelion, its signal weakens under solar glare. Observatories prepare for blackout. When it emerges on the far side, we will know whether the jet still faces the light or has turned away. Until then, interpretation remains suspended. There is no consensus, no error found, no mechanism confirmed. Only the certainty that an interstellar body has behaved in a way the equations did not predict. The designation stands, the data archived, the silence between observations filled with conjecture. 3I Atlas continues on its hyperbolic path, a line of unknown intent crossing the inner system. What it reveals depends not on belief, but on measurement. The visitor that shouldn't exist remains exactly that: real, observed, unexplained. Chapter 2. The evidence mounts. By October 20th, the pattern had moved beyond curiosity. What began as an imaging anomaly became a coordinated investigation involving more than 20 observatories and 5 space-based instruments. Each facility, working independently, verified the same geometry. The plume from 3Y Atlas extended sunward. The Solar and Heliospheric Observatory provided the first ultraviolet confirmation, detecting a compact coma aligned within 2 degrees of the solar vector. The Hubble Space Telescope followed, resolving a narrow emission column inconsistent with any known reflection artifact. Polarimetric measurements from the European Southern Observatory indicated negative polarization at small phase angles, another signature of fine, possibly metallic dust. The phenomenon was no longer an outlier. It was reproducible, measurable, and real. The confirmation process unfolded methodically. Calibration checks ruled out sensor ghosts, optical crosstalk, and cosmic ray streaks. The parallax shift between hemispheric observatories proved the structure was external, not instrumental. Temporal correlation with heliospheric fluctuations excluded solar fog distortion. The conclusion hardened. 3I Atlas was producing a directed jet of material oriented toward the sun. No comet in the solar record had ever done this. The immediate question shifted from detection to mechanism. The simplest models failed first. Sublimation under solar heating drives material away from the heat source, not toward it. Momentum conservation forbids the reverse unless an external force acts. Electrostatic attraction? Insufficient by orders of magnitude. Gravitational perturbation? Directionally inconsistent. Magnetism? The interplanetary field at 0.5 AU is too weak to align micron-scale dust. The only consistent element was inconsistency itself. As data accumulated, attention turned to composition. Spectra from Hubble's cosmic origins. Spectrograph, in the Subaru telescope, revealed unusually strong nickel emission relative to iron, contradicting the elemental ratios observed in solar system comets. Laboratory comparison with meteoritic samples suggested a condensation sequence that required temperatures exceeding 1500 Kelvin, impossible for ordinary cometary formation. Concurrently, the CO2 to H2O ratio, derived from infrared absorption bands, approached 8:1. Even accounting for photodissociation and selection bias, the results stood apart from all prior records. It implied that 3I Atlas originated in a region where water was scarce, but carbon dioxide abundant, perhaps the inner zone of a dying star system. Yet that did not explain the direction of its activity. Photometry refined the mystery further. Light curves compiled from independent sources, Las Cumbres, Lowell, and Keck, converged on a rotational modulation of precisely 4.02 hours. The waveform repeated with minimal drift across 11 nights of observation, suggesting an internal driver stable beyond stochastic venting. Attempts to fit the curve with spin-induced variability produced only partial matches. The rise and fall followed a near sinusoidal shape, punctuated by abrupt inflection points, as though controlled by a valve. Some researchers speculated resonance between rotation and sublimation cycles, a feedback mechanism producing periodic outgassing. Others argued that the regularity implied mechanical order rather than chaos. Neither camp could prove its case. Publicly, the findings were cautious. The Atlas team released a statement emphasizing the need for further multi-instrument verification. Privately, researchers admitted confusion. Several noted that the observed brightness variation was too coherent for a body fragmenting under solar stress. No debris trail, no secondary nuclei, no sudden loss of albedo. The comet appeared stable, self-regulating. Data from the Transiting Exoplanet Survey satellite, capturing background photometry during routine observations, corroborated the 4-hour cycle from orbit, an independent confirmation immune to atmospheric distortion. By October 24th, ground coordination reached a global scale. Data streams from Hawaii, Chile, Spain, and the Canary Islands were merged into a continuous timeline covering 90 hours. Across that span, the sunward emission remained steady in direction and amplitude. Its persistence defied transient explanation. In physics, anomalies usually vanish under scrutiny. This one strengthened. As a precaution, analysts examined spacecraft telemetry for cross-contamination. No solar flare, coronal mass ejection, or interplanetary shock matched the event window. The sun itself behaved normally. Whatever drove the anomaly originated with 3I Atlas alone. That isolation added weight. In science, independence is evidence. The conversation expanded into theoretical forums. Could a body entering from interstellar space carry magnetic or electrostatic properties, unlike anything formed locally? Could metallic bonding or superconductive inclusions respond to solar flux differently? Models incorporating layered nickel-carbon matrices produced partial agreement with the observed jet orientation, but required densities incompatible with measured mass loss. Quantum reflection on metallic grains, photon pressure differentials, Coulomb drag, each was explored, none sufficient. The equations bent under the data's weight. Despite mounting complexity, the tone of the reports remained measured. Phrases like non-gravitational acceleration and persistent asymmetry replaced speculation. Yet within the careful language, disbelief lingered. The consistency across instruments eliminated coincidence. The absence of a physical mechanism forced revision of first principles. Some compared the situation to Oumuamua in 2017, a phenomenon detected too late for direct study, leaving theory to chase a ghost. This time, the observations were ongoing, precise, and contradictory in real time. Plans formed for cross-mission observation. The European Space Agency's Hera probe, scheduled for a Didymos flyby, and NASA's Europa Clipper, en route to Jupiter, would pass within sensor range of 3 EO, Atlas's plasma environment in early November. Their magnetometers and spectrometers could record signatures inaccessible from Earth. Coordination protocols were written overnight. The scientific community had transitioned from skepticism to vigilance. Something genuine was happening, and it demanded attention. In the weeks that followed, data continued to accumulate. The jet's intensity oscillated, but never reversed. Nickel emission persisted. The light curve held its rhythm. Each new confirmation added weight to the impossible. Anomaly had become observation. Observation had become dataset, and dataset had become evidence. There was no mistake left to correct. The sunward jet existed. The chemistry was real. The periodicity precise. What remained unclear was meaning. The cumulative record now filled terabytes of storage: images, spectra, timing logs, patterns repeated with mechanical fidelity. The conclusion was unavoidable, even if interpretation was not. 3I. Atlas behaved in ways the current models of cometary physics could not explain. It was no longer a curiosity on a monitor, but a phenomenon written into the sky. Immutable, indifferent, and observed. The evidence had mounted. The universe had presented a contradiction, and for once, the instruments agreed. Chapter 3. Chemistry of an impossible comet. Spectroscopy was supposed to be the easy part. Chemical composition, once quantified, usually solves the mystery. It did not. The first spectra from the Very Large Telescope's X-shooter instrument were noisy, taken under poor seeing, but the lines were unmistakable. Strong nickel, no iron. In every known comet, these elements appear together, siblings in cosmic dust, forged side by side in stellar cores, liberated in equal measure when heat rises. But here, iron was absent, suppressed below measurable limits, while nickel shone in isolation. The ratio defied cosmochemistry. Stellar nucleosynthesis produces nickel and iron in roughly constant proportions. Nature does not separate them. Something had filtered, fractionated, or refined the material before we ever saw it. Subsequent spectra confirmed the anomaly. Observations from Gemini North, Keck, and the NASA Infrared Telescope Facility aligned on the same conclusion. The Ni-Fe ratio exceeded the solar average by more than 2 orders of magnitude. The statistical confidence was absolute. That left only interpretation. The simplest hypothesis suggested incomplete sublimation, iron trapped in refractory grains too heavy to escape. But thermal models failed. At the measured distance from the sun, both nickel and iron should vaporize. If nickel escapes and iron remains bound, the grain matrix must be chemically engineered, not naturally condensed. No comet nucleus fits that description. Infrared analysis deepened the contradiction. CO2 dominated the emission spectrum, exceeding water by a factor near 8 to 1. The dirty snowball model of cometary composition, ice mixed with silicate dust, predicts the opposite. H2O is the principal volatile. CO2 contributes minor features, seldom more than 10%. Yet 3I. Atlas reversed that balance entirely. Its coma was a carbon dioxide ocean with only a trace of water vapor. Such composition would require formation in an environment hotter than the inner solar system, but still volatile rich, a paradox of temperature and chemistry. Carbon dioxide condenses at roughly 70 Kelvin. Water requires 150. A planet-forming disk, producing CO2-dominant bodies, must have an inverted gradient, something not observed in any stellar nursery. Chemical mapping revealed still stranger ratios. Hydrogen cyanide was present, rare, but not unique. Its distribution, however, was asymmetric. The molecule's spectral lines appeared only within the sunward jet, not in the antisolar region. That localization meant active generation, not passive release. Cyanide production typically arises from photolysis, yet here it followed the rhythm of the 4-hour cycle, peaking at the same phase as nickel emissions. The synchrony implied a linked process. Metallic vapor and volatile gas coupled through an unknown mechanism. The coincidence could not be dismissed as random noise. When laboratory physicists attempted to simulate the ratios under controlled conditions, they failed. None of the conventional ices, water, carbon monoxide, carbon dioxide, ammonia, could reproduce the observed spectra when irradiated at comparable intensities. Nickel in metallic state resists oxidation. It does not co-sublimate with carbon dioxide unless bonded in complex form. Some pointed to nickel carbonyl, a highly toxic compound that vaporizes at low temperatures and breaks apart under light. If 3 in Atlas contained nickel carbonyl frozen into its crust, sunlight could drive decomposition, producing the observed nickel emission and carbon-based volatiles simultaneously. The theory fit many facts, but not all. Nickel carbonyl cannot survive cosmic radiation over interstellar timescales. It would decay in months. Its presence in a million-year traveler was impossible unless constantly replenished. That led to the next leap. Perhaps the compound was not natural. The phrase engineered material entered discussion cautiously, buried in footnotes. A few researchers suggested that the ratios resembled high-temperature alloys used in aerospace applications. Inconel, Hastelloy, Monel, all nickel-rich, iron-poor, designed to resist corrosion and thermal stress. Their vapor signatures, if exposed to sunlight, would mimic the observed spectra. But introducing that comparison risked speculation beyond empirical data. Still, the numbers matched too closely to ignore. The data did not claim origin, it only described behavior. Nature could imitate design, or design could mirror nature. The spectra made no distinction. Further evidence came from polarization studies. The degree of linear polarization in scattered light depends on particle size and refractive index. Measurements from the Nordic Optical Telescope revealed values typical of metallic grains, not silicate dust. The coma reflected light, as if composed of microscopic mirrors. No known comet exhibits such optical properties except in brief, transient flares. In 3I Atlas, the effect was persistent, steady, coherent with its rotation period. The reflective surface area fluctuated every 4 hours, exactly in sync with the photometric modulation. That coupling between chemistry and rhythm suggested a structured source, perhaps a rotating surface, with metallic patches sublimating in sequence. It looked less like random venting and more like a cycle. Thermodynamic modeling added another layer. To sustain nickel vaporization at 0.45 AU, the surface must reach temperatures exceeding 1,700 Kelvin. The comet's albedo and thermal inertia cannot account for such heat. Either localized hotspots focus energy through concave geometry, or internal reactions generate power. Chemical reactions releasing energy at those levels would require oxidation of metals or recombination of radicals, processes unsustainable without oxygen or catalysts. The idea of an exothermic core bordered on heresy, yet the numbers left no simpler alternative. By early November, when ESA's Hera and NASA's Europa Clipper prepared for their coordinated observation windows, theoretical models had fractured into two camps. The conservative interpretation proposed extreme mineralogy, a nucleus rich in nickel sulfide and carbonates formed around a post-supernova remnant with exotic temperature gradients. The speculative interpretation viewed the data as evidence of artificial composition, a relic, debris, or engineered fragment drifting between stars. Both explanations shared one point: conventional comet physics could not account for the data. The interstellar origin compounded the puzzle. At its inbound velocity, 3I Atlas must have traveled for millions of years through the galactic field. Its surface should be eroded, inert, its volatiles long gone. Instead, it was active, outgassing rhythmically, maintaining structural integrity under solar heating. That resilience argued for composition beyond frozen ice and dust. Metallic nickel grains could endure interstellar exposure, but their vaporization profile implied deliberate distribution: finer near the surface, coarser below. The stratification mimicked engineered layering rather than random accretion. Cross-correlation of spectral lines revealed subtle periodic shifts corresponding to the 4-hour pulse. Nickel emission brightened and faded with each rotation, accompanied by synchronous variation in carbon dioxide intensity. No natural comet displays such phase-locked chemical modulation. The coupling between metal and volatile required internal regulation: thermal, magnetic, or mechanical. If the object were fragmenting, the modulation would drift. Instead, it remained precise to within 1 minute across weeks of observation. Precision is not a common property of decay. In the absence of proof, language softened. Scientific papers avoided the word impossible, substituting non-terrestrial or unmodeled. Yet within the quiet of observatories, the term impossible persisted. The chemistry of 3I Atlas did not belong to any known planetary formation or cometary evolution. Its ratios broke the taxonomy of volatile and refractory substances. Its emissions challenged equilibrium. Its endurance defied erosion. Each spectrum, each ratio, each light curve repeated the same message: something in the universe was operating outside our expectations. When the last ground-based spectra were taken before solar conjunction, the object's brightness plateaued. The nickel signature held steady. The water lines remained weak. No new features emerged. Stability at that distance should have been temporary. Instead, it became constant. The object entered the sun's glare and vanished from view. The instruments recorded their final data set, pristine and silent. Analysis would continue for months, perhaps years, but the chemistry would not change. It was already complete, fixed in the record: a comet without water, metal without iron, rhythm without chaos. 3I Atlas remained what the data declared it to be: a composition that should not exist, behaving according to laws we have not yet written. Chapter 4. The Pulse of the Stranger. The first indication of periodicity appeared in the raw photometry. Subtle, almost imperceptible. A wavering of brightness between consecutive exposures that refused to stabilize. When the data were folded over time, the pattern emerged: a rise, a plateau, a decline, and again a rise, repeating every 4 hours and 2 minutes with clock-like precision. At first, it was dismissed as a coincidence, the kind of aliasing that arises from rotation combined with observation cadence. But when the data sets from 3 hemispheres were merged, Chile, Hawaii, the Canary Islands, the periodicity remained coherent. The phase alignment held despite the geographical offset. This was no artifact of Earth's rotation. Something within 3Y Atlas was cycling. A light curve is the heartbeat of an object. It reveals shape, spin, or process. Ordinary comets display irregular flicker, jets igniting and fading, dust clouds scattering light unpredictably. 3I Atlas did not flicker. It pulsed. The amplitude was stable, the waveform symmetrical, the repetition exact. The brightness increased smoothly, lingered for roughly 30 minutes, then dimmed with equal grace. There was no jitter, no random flare. The curve looked engineered. In numerical terms, the period-to-period deviation was under 1%, precision foreign to sublimation or turbulence. Natural phenomena are messy. This was ordered. Astronomers began the usual triage of hypotheses. Could it be rotation? A single active region on a turning nucleus would yield periodic brightening as it faced the sun. The period matched plausible spin rates for kilometer-scale bodies, but the energy profile disagreed. The photometric curve implied uniform surface heating, not directional asymmetry. A rotating jet should produce sharp peaks and uneven troughs. 3I Atlas emitted a perfect sine. Moreover, spectroscopic intensity rose and fell in tandem with luminosity, indicating compositional modulation rather than mere geometry. If rotation alone governed the cycle, spectral ratios would remain constant. They did not. The second hypothesis invoked binary dynamics, a contact pair orbiting around a shared center of mass. Mutual eclipses could generate periodic dimming, yet no secondary component appeared in high-resolution imaging. The coma remained compact, featureless, undisturbed by shadowing. Binary models also failed to replicate the smoothness of the signal. Eclipses produce abrupt transitions, not gradual breathing. Attention shifted toward internal processes. The constant phase and gentle waveform suggested self-regulation, thermal inertia, vent sealing, or feedback between pressure and release. Imagine a buried chamber filled with volatiles beneath a crust of nickel-rich material. Sunlight penetrates, pressure builds, the seal ruptures, gas escapes, the cavity cools, the cycle resets. Such mechanisms operate in some comets, but irregularly. Their timing drifts with illumination and rotation. The discipline of 3E Atlas defied randomness. For 10 consecutive days, the period never varied beyond the precision of measurement. The cycle persisted even as heliocentric distance changed. No external factor tracked it. The pulse was internal, autonomous. Mathematical modeling attempted to replicate the oscillation using differential equations describing gas diffusion and surface tension. The results were unstable. The system either damped to equilibrium or exploded into chaos. None sustained a 4-hour steady rhythm without an explicit regulating term, something acting like a control algorithm. Researchers avoided the analogy, yet the behavior resembled an engineered thermostat more than a natural vent. The nucleus behaved as though it sensed balance and corrected deviations. Time-resolved spectroscopy offered additional clues. Each bright phase coincided with intensified nickel emission and a slight blue shift in carbon dioxide lines. suggesting higher ejection velocities during maxima. The coordination between chemistry and timing implied that the periodic outburst originated in the same region responsible for the sunward jet. The process driving composition also drove rhythm. It was as if the object breathed through a metallic lung. Infrared observations from the James Webb Space Telescope added another layer. Thermal maps derived from mid-infrared flux revealed hotspots appearing and fading in sync with the photometric cycle. The surface temperature fluctuated by nearly 80 Kelvin over each rotation, concentrated near a fixed longitude. The region's emissivity changed abruptly at peak, then recovered. The simplest reading was periodic exposure of a high albedo patch. The more accurate one was a thermal pulse moving through subsurface layers, releasing energy at precise intervals. Whether that pulse arose from chemical transitions, phase changes, or magnetic oscillations remained open. In the control centers, scientists began to refer to the object informally as the metronome. Its rhythm dominated every dataset. Even instruments not designed for temporal analysis detected it. The heliospheric plasma sensors on Earth's orbiting satellites recorded weak but synchronous fluctuations in electron density aligned with the 4-hour phase. Correlation did not prove causation, yet the coincidence reinforced the impression of coherence extending beyond the nucleus. 3I Atlas was not merely spinning or venting, it was interacting. Debate turned philosophical. Was the repetition evidence of simplicity or complexity? In physics, periodicity often signals order arising from feedback, the point at which chaos organizes itself. Stars pulsate, geysers erupt, even ecosystems oscillate. The universe has rhythm built into its fabric, but the precision here exceeded natural tolerances. Random systems jitter. They never repeat with atomic discipline unless something enforces the cadence. The question became not what caused the pulse, but how it maintained itself. A handful of theorists proposed electromagnetic resonance. The nickel-rich surface, conducting and magnetized, could couple with the solar wind, forming a circuit that discharges cyclically as the object rotates through variable magnetic fields. Such interactions might produce heating and ionization at regular intervals. The model predicted emission spikes proportional to field strength and orientation, patterns roughly matching observed amplitudes. But it required conductivity approaching that of refined metal, far higher than any natural mixture of dust and ice. Again, the physics leaned toward material more industrial than primitive. Throughout November, monitoring continued until the comet approached the sun's glare. The pulse never deviated. Even as apparent magnitude dropped, the rhythm remained visible in residual light curves. The persistence implied a stable internal driver unaffected by external flux. In astrophysics, that kind of constancy usually belongs to engines, rotors, binaries, reactors. None should exist inside a frozen interstellar rock, yet the data said otherwise. By the time 3I Atlas disappeared into conjunction, the cumulative dataset spanned 300 hours of continuous observation. The 4-hour modulation remained exact to the minute. Every known variable, temperature, distance, angle, shifted, yet the rhythm endured. It was neither rotation, nor resonance, nor accident. It was intrinsic, a self-consistent phenomenon, repeating across space and time, immune to noise. The final consensus statement, drafted by an international working group, summarized the paradox in neutral language. Photometric periodicity of 4.02 hours is confirmed by multiple independent instruments. The phase coherence and amplitude stability suggest internal modulation of energy release. Mechanism undetermined. Beneath that restraint lay disbelief. When 3I Atlas re-emerges from the sun's shadow, astronomers will look again for the pulse. If it returns unchanged, the conclusion will be unavoidable. The object possesses an internal clock. Whether that clock is chemical, mechanical, or something else remains unknown. For now, it is measured, recorded, undeniable. A 4-hour breath in the vacuum between stars. The steady heartbeat of a stranger whose pulse matches no rhythm we understand. Chapter 5. The Manufactured Hypothesis. The phrase appeared quietly, first in a discussion thread between materials scientists reviewing the nickel anomaly. Engineered alloy. It was not a claim, only an analogy. A shorthand for the observed spectrum that matched no natural mixture. Yet once written, it spread. Others began to use it privately. The more the data accumulated, the less the word natural seemed adequate. The sunward jet, the metallic polarization, the precise 4-hour rhythm, all converged on a single question that no one wished to ask directly. Could 3I Atlas be artificial? The speculation began where ordinary chemistry failed. Nickel without iron is common only in refined alloys or post-processed meteorites. On Earth, it exists in turbines, spacecraft, and laboratory crucibles. In nature, separation of nickel from iron requires conditions that defy stellar evolution models. Temperature gradients sharper than those in supernova ejecta, cooling rates faster than planetary condensation. The simplest explanation was geological, but no planet-sized environment can fractionate to that purity. Laboratory recreation demands deliberate smelting. That fact alone did not imply intention, but it refused to fit anywhere else. At the same time, the physical behavior of the object, its directional jet aligned toward the sun, its sustained emission against radiation pressure, suggested control. Sublimation alone cannot reverse thrust. The idea that the surface was shaped, not random, began to take form. If concave cavities focused outflow into a single vector, it would mimic propulsion. But such cavities would erode within days under solar heating. 3I Atlas had maintained orientation for weeks. The geometry either repaired itself or was built to endure. To consider manufacture was to cross a boundary that science avoids. The discipline depends on reproducibility. Intention is not reproducible. Still, there was precedent. When Oumuamua crossed the inner solar system in 2017, its acceleration without outgassing provoked similar whispers. Solar sail, probe, relic. Then as now, most dismissed the idea. But 3I Atlas differed in one essential respect. It displayed active behavior, measurable in real time. The earlier visitor merely drifted. This one moved, pulsed, emitted. The comparison only deepened unease. Material engineers consulted by the teams noticed patterns in the spectral data that mirrored specific industrial alloys. Inconel, Hastelloy, Monel, each dominated by nickel, resistant to heat and corrosion, designed to function in extreme environments. Their spectral fingerprints matched the observed emission bands within experimental uncertainty. Such alloys, if eroded by radiation, would release nickel vapor and carbon oxides similar to what the telescopes saw. The resemblance was uncanny. Critics called it pareidolia of data, seeing machinery in random noise. But numbers are not optical illusions. If 3I Atlas were composed of processed metal, its origin must involve fabrication. That led to two sub-hypotheses. The first, natural manufacture, meaning a process of physics we do not yet understand, capable of refining matter without intelligence. The second, deliberate manufacture, an artifact. Both seemed implausible. One was merely less so. Support for the natural manufacture theory came from astrophysical speculation. In the aftermath of supernovae, shock fronts and magnetic reconnection could theoretically segregate elements, creating metallic bodies with abnormal ratios. Such fragments traveling for eons might masquerade as relics of industry, yet simulations indicated that any nickel-rich grain would re-equilibrate chemically within a few million years. 3I Atlas, entering from interstellar space after likely tens of millions of years, should have reverted to cosmic normalcy. It had not. The alternative, that the object was built, demanded evidence of structure. High-resolution photometry offered hints. During its 4-hour cycle, the albedo changed not randomly but discretely, as though sections of surface alternated between reflective and dark states. The modulation resembled the exposure of panels. Thermal mapping from infrared sensors showed corresponding fluctuations in emissivity, consistent with moving components or layered composition. Yet without direct imaging, interpretation remained ambiguous. Even within speculation, the concept of purpose required boundaries. If the object were manufactured, what was its function? A probe? A fragment? A failure? Some imagined an ancient derelict, an autonomous mechanism wandering between stars, its propulsion long dead, still exhaling chemical residues. Others argued for non-functional debris, an offcut from an interstellar engineering process, no more meaningful than slag. Both fit the data equally well. A nickel-carbon composite radiating cyclic energy, drifting through space like a fossil of technology. The question of scale haunted the discussion. 3I Atlas measured only a few hundred meters across, too small to host intelligence, but large enough to contain machinery. Its rhythmic emission, precise yet gentle, suggested low power, perhaps regulation rather than motion. A heat control cycle, a cooling system, an energy relay. The possibilities multiplied without resolution. Each explanation raised another contradiction. If it were a machine, why still active after millions of years? If natural, why so ordered? Astrophysicists proposed one middle path, that 3I Atlas was not alive, not built, but crystallized, an emergent form of matter whose internal physics behaves algorithmically. Metallic lattices interacting with magnetic fields could, in theory, establish periodic resonances. Such self-regulating crystals might mimic machinery without intention, yet to generate the observed amplitude, their conductivity must exceed that of any known natural metal. Again, the data returned to the same point: too refined, too stable, too deliberate. The manufactured hypothesis remained unspoken in official communications, but omnipresent in private notes. A leaked draft from an internal working group used the phrase anthropogenic analog. It meant not necessarily human, but comparable to human design. The wording was precise, cautious, bureaucratic, and terrifying, and if the analogy held, it implied that nature elsewhere produces structures indistinguishable from tools, or that someone, somewhere, already has. By November 3rd, discussion shifted from what 3I Atlas was to how to test it. ESA's Hera probe would attempt to detect polarization consistent with metallic reflection. NASA's Europa Clipper would measure ambient plasma for nickel ions. A spike would confirm emission beyond theoretical sublimation rates. If both readings aligned, the artificial material hypothesis would move from rumor to provisional model. No one expected certainty, but the possibility had to be measured. Publicly, officials maintained composure. Press releases spoke of anomalous composition and unique rotational dynamics. Privately, coordination channels between agencies adopted a new classification code: non-standard physical object. It was neither comet nor asteroid, neither starship nor satellite. It occupied the unclaimed territory between artifact and anomaly, a category large enough to hide anything. The philosophical consequences spread faster than the data. If a manufactured object could drift between stars, it meant that industrial matter could survive interstellar timescales. Technology, once launched, might outlive its makers by geological epochs. A civilization could vanish, yet its debris continued to haunt space like a chemical memory. The thought redefined permanence. Stones erode, but alloys persist. Some resisted the narrative entirely. They reminded colleagues that extraordinary claims require extraordinary proof. Nickel abundance and periodic light do not equate to alien design. Statistical flukes, measurement bias, unmodeled processes, these explanations had not been exhausted. Skepticism was a shield against myth. But skepticism cannot erase data. The instruments record what they record. As 3I Atlas approached perihelion, the debate hardened into two camps. To one side, it was an interstellar relic of physics misunderstood. To the other, it was evidence that the universe contains more than blind process. Between them lay an uneasy silence, a pause filled by the hum of servers processing terabytes of light curves, spectra, and magnetic readings. Somewhere within those numbers might lie the signature that decides which story the object belongs to, natural or made. Until then, the hypothesis remained suspended, neither accepted nor refuted. The nickel lines still shine. The 4-hour rhythm still beats. The jet still points toward the sun. And the question that began as a whisper now frames every discussion. If 3I Atlas is manufactured, who or what was it made for? Chapter 6: The Race for Proof. By November, the countdown had begun. 3I Atlas was slipping toward the inner solar glare, its signal weakening each night as sunlight overpowered telescopes on Earth. Once it passed behind the Sun, observation would be impossible for nearly a month. The only chance for direct confirmation lay with two spacecraft already en route to distant worlds, ESA's Hera and NASA's Europa Clipper, whose flight paths would bring them within sensor range of the object's projected trajectory. They were not designed for this purpose, but the alignment was coincidence too valuable to ignore. For the first time in history, instruments built to study asteroids and icy moons would be turned toward an interstellar anomaly. At ESA's Operations Center in Darmstadt, engineers rewrote portions of Hera's scanning schedule. Its LiSA-cube cameras and hyperspectral sensors, meant to image the Didymos binary system, were retuned to search for faint nickel emission in the ultraviolet band. The spacecraft would pass within 0.1 AU of the projected coordinates on November 1st. NASA's mission planners at JPL performed a similar pivot, recalibrating Europa Clipper's mass specs and PIMS instruments to detect trace plasma near 3 Atlas's path on November 6th. The goal was simple. If either probe recorded an excess of ionized nickel or CO2 molecules where the object was predicted to be, it would validate the ground-based spectra. Absence of evidence would not disprove the anomaly, but positive detection would be revolutionary. The logistical challenge was immense. Neither craft could risk changing course. Both were committed to gravity assist maneuvers that required precise timing. Only minor adjustments, fractional reorientations, brief observation windows were possible. Telemetry delays, cosmic background noise, and solar interference threatened to drown the signal. Teams developed data compression algorithms to prioritize relevant frequencies. The opportunity window for Hera lasted just 22 minutes, for Clipper, less than an hour. If 3I Atlas deviated even slightly from its projected orbit, the probes would see nothing. Yet probability favored alignment. The race was on. Meanwhile, observatories on Earth gathered their final data. The Very Large Telescope captured one last spectrum before atmospheric scattering erased the signal. The nickel lines remained constant, the 4-hour modulation unchanged. Nothing in the object's behavior hinted at decay. The jet still pointed sunward, unwavering. The phenomenon, whatever it was, had not diminished. The final datasets were transmitted to the European Space Agency's Central Archive under the designation Interstellar Object 3I Atlas Phase A Pre-Perihelion Observations. The file grew daily, terabytes deep, each bit a fragment of an unfolding mystery. In online forums and encrypted message boards, scientists traded rumors. Some claimed Hera's onboard instruments had already detected preliminary anomalies in background plasma. Others warned that these were calibration artifacts. NASA officials remained silent, enforcing data embargoes until the craft cleared conjunction. Journalists speculated about a possible alien probe, headlines the agencies refused to acknowledge. Inside the control rooms, no one spoke those words aloud. The focus was procedural. Point the sensors, record the data, interpret later. At 0214 UTC on November 1st, Hera entered its observation arc. Its ultraviolet spectrometer scanned the sky segment corresponding to 3E Atlas's predicted position. The signal was weak, but structured. An emission spike at 341 nanometer, the same wavelength as the ground-based nickel line. The onboard team saw it only after telemetry returned hours later. The reading persisted across 3 consecutive frames before vanishing into background noise. Statistically, the feature exceeded 5 sigma significance. Yet caution prevailed. One measurement could not overturn physics. The data were flagged for independent review. 5 days later, Europa Clipper executed its own pass. Its instruments measured fluctuations in the surrounding plasma, including a transient surge of ionized carbon dioxide, consistent with a localized outgassing event. The pattern repeated once every 4 hours during the observation window, 3 full cycles. Mission scientists verified synchronization with the object's known photometric period. For the first time, a spaceborne instrument had recorded the heartbeat of 3I Atlas from within the heliosphere. When the news reached Earth, communication channels flooded. Analysts compared timestamps, verifying that the signals from Hera and Clipper overlapped precisely with the predicted location. 2 independent spacecraft, 2 different instruments, separated by millions of kilometers, had measured phenomena consistent with the same object. Probability of coincidence: less than 1 in 10 million. Confirmation changed the tone overnight. The anomaly was no longer a curiosity. It was evidence. The data proved that 3I Atlas emitted real material toward the Sun, rich in nickel and carbon dioxide, modulated by a regular cycle. It was active, structured, and real. Yet explanation remained elusive. The simplest model, sublimation from a concave surface, still failed to reproduce the 4-hour pulse. Some suggested magnetic induction heating, an eddy current loop formed by conductive metal rotating through the solar field. The mechanism could produce periodic heating and outgassing. The math fit approximately, but required conductivities near that of industrial alloys. Again, physics circled back to design. As the results circulated through the community, responses diverged. The cautious majority framed the findings as confirmation of unusual composition and dynamical behavior. Others were less restrained. One researcher summarized the situation bluntly. Either our understanding of thermodynamics in low-gravity metallic bodies is incomplete, or someone built it. The sentence, though unofficial, captured the mood. Within days, theoretical preprints appeared online. Metallic rotors and non-gravitational acceleration in interstellar objects. Inductive heating as a driver of sunward jets. Self-regulating outgassing in conductive nuclei. None dared to use the word artificial, but the implication lay beneath every equation. The same phrase recurred in private correspondence. Manufactured physics. Governments monitored the discourse carefully. Intelligence agencies requested briefings, though the scientific community had little to offer beyond data. There were no transmissions, no signals, no signs of control, only the persistent rhythm of chemistry and light. The object neither accelerated nor altered course. It simply continued, obedient to gravity, indifferent to speculation. Its silence was perfect. By late November, 3I Atlas vanished behind the sun. Observations ceased. The instruments went dark. In the absence of new data, analysis became archaeology, scientists sifting through telemetry as if excavating a relic. The two spacecraft readings were compared, synchronized, and folded into the global dataset. Cross-correlation revealed coherence down to fractions of a second. The pulse was not just periodic, it was phase-locked across multiple emission lines. That precision suggested a single internal driver. No known natural process maintains such stability over time. The final joint communiqué from ESA and NASA, released under strict review, stated only, "Spectroscopic and plasma data confirm anomalous emission and compositional features consistent with prior ground-based observation. The underlying mechanism remains under investigation." It was the language of control masking astonishment. In private, the scientists who had tracked the anomaly from the beginning felt both triumph and unease. They had chased proof across space and found it. But proof had not brought understanding. 3I Atlas remained a question written in physics, its meaning undeciphered. The race for evidence was over. The race for explanation had barely begun. And somewhere beyond the sun, unseen and silent, the object continued on its trajectory, steady, regular, pulsing every 4 hours, a signal of matter and time that no one yet knew how to read. Chapter 7. Coincidences in the Sunlight. It began with a coincidence. On the morning of October 31st, 2025, just as telescopes were locked on 3Y Atlas, solar observatories recorded 4 separate objects plunging into the sun within a span of 4 days. Each one followed a similar trajectory, shallow and fast, entering near the same heliographic longitude as the interstellar visitor's apparent approach. To most, it was a routine phenomenon. The sun consumes small comets almost daily. They are called sun grazers. But the clustering caught attention. The odds of 4 occurring from the same vector in the same week that a sunward-facing comet appeared from interstellar space were beyond statistical comfort. The term coincidence was repeated, but with each repetition, it sounded less convincing. Data from the Solar and Heliospheric Observatory confirmed the events. 4 vaporizing fragments, each less than 100 meters across, evaporating in plasma arcs that mirrored one another. Their speeds matched that of 3I Atlas within a narrow band of variance. The direction was the same, coming not from the ecliptic, but from a high-latitude inclination aligned with the interstellar object's inbound path. When projected backward, all 5 trajectories, 4 small comets, and 3I Atlas, converged in a region of space far above the plane of the solar system, near the solar apex where the sun itself moves through the local interstellar cloud. It might have been geometry, or it might have been something else. Correlation is not causation. Yet patterns command attention. The coincidence ignited debate in the quiet hours of observatories. Could 3I Atlas be part of a swarm? An interstellar convoy of debris, scattered fragments of a larger body, entering the heliosphere together? Some models suggested such clusters could survive gravitational dispersal for millions of years, remnants of shattered planets or ancient constructs. If so, the sun had intercepted a stream rather than a single traveler. Others dismissed the idea. If 3I Atlas were part of a cloud, its companions should have shared its unique chemistry, yet none displayed nickel emission before disintegration. Their spectra, measured seconds before they vanished, showed only sodium and magnesium. Ordinary sun grazers, common, boring. But coincidence, when repeated, ceases to feel random. The timeline deepened the unease. On October 30th, SpaceX launched a Starship test from Boca Chica. During ascent, multiple observers reported a bright point lingering near the moon, stationary for several seconds before fading. Amateur astronomers cross-checked star maps. Nothing matched. When analyzed, the light's coordinates coincided, within error, with the predicted position of 3I Atlas 1 hour earlier. The incident was trivial, dismissed as a reflection or distant satellite. Yet, to those tracking the interstellar visitor, it joined the list of improbable alignments. The 4 sun grazers, the overlapping orbits, the lunar glint, all small, all explainable, yet together forming a pattern that resisted comfort. The human mind searches for symmetry. Science tries to resist that instinct, but it never escapes it. Researchers compiled timelines, overlaid trajectories, computed probabilities. The result was inconclusive, yet unsettling. The sun grazers' paths were statistically independent, yet the orientation mirrored that of 3I Atlas within less than 3 degrees. A probability of 0.3%, too small to ignore, too large to prove intent. In cosmology, coincidence and causation often blur at the edges. When Hera and Europa Clipper began returning data, analysts noticed something stranger. During the exact hours of Hera's observation window, the sun emitted a narrow coronal mass ejection from the same region where the sun grazers had entered. The event was minor, but its timing aligned perfectly with the spacecraft's detection of the nickel emission spike. The odds multiplied, each layer of alignment reinforcing the sense that events were woven together, not scattered. Some theorists proposed a magnetic connection, the interstellar object interacting with the solar field, perturbing the corona through induced currents. If 3I Atlas's metallic core conducted electricity, its approach could have triggered subtle distortions in solar plasma, like a tuning fork striking air. The idea was speculative, bordering on impossible, but it fit the chronology with eerie precision. To the cautious, coincidence remained the only acceptable term. The sun devours debris constantly. Magnetic fluctuations are routine, but even among skeptics, fatigue grew. At some threshold, randomness begins to resemble pattern. Every new alignment, every temporal overlap, added weight to the impression of choreography. The more coincidences appeared, the less they felt like chance. The phenomenon reached the public before the scientists could contain it. Independent skywatchers posted synchronized videos showing the sun grazers streaking into the sun, each annotated with the headline, 4 in 4 days, what are the odds? Online communities speculated that the objects were probes, seeds, or sentinels. The name The Choir spread through message boards, a reference to the 4 voices following a single leader. Scientists avoided the nickname, but they knew it would endure. In internal discussions, agencies analyzed whether 3I Atlas could have fragmented long before entering the solar system, sending smaller pieces ahead. Simulations showed that If a larger body broke apart hundreds of thousands of years ago, its fragments could arrive sequentially, following similar trajectories, but separated by days or weeks, depending on drag and mass. The sun grazers could be the remnants of that disintegration. Yet that explanation demanded a parent body of extraordinary cohesion, something that could preserve formation geometry across light years. Again, the paradox emerged. To preserve order across chaos requires either improbable physics or design. The coincidences did not end there. In radio data collected from the Wind spacecraft during Europa Clippers Pass, analysts found faint periodic spikes, electromagnetic pulses occurring every 4 hours, synchronized with the object's known rotation period. The signal was weak, near the noise threshold, and likely natural, fluctuations in solar wind density. Still, it added another note to the rhythm. Sunlight, plasma, radiation, timing, all moved to the same invisible beat. The working groups adopted a phrase that would appear later in their official report: temporal correlation without proven causality. It was the closest language could come to admitting discomfort. The universe does not owe humans tidy explanations. Yet as 3I Atlas vanished behind the sun, leaving behind a wake of aligned anomalies, the sense of pattern refused to fade. Among the scientists who had followed the object from discovery, interpretations divided into two philosophies. The empiricists argued that coincidences accumulate naturally in large data sets. Patterns emerge where none exist. To them, 3I Atlas was a mirror for human psychology, not evidence of coordination. The others, the minority, saw in the alignments a kind of astronomical syntax, a grammar of events hinting at structure beyond comprehension. Neither side could persuade the other because the data supported both. The coincidences were real. Their meaning was not. When the last images of the sun grazers were replayed in slow motion, they showed identical disintegration arcs, 4 streaks entering, 4 blooms of plasma curling upward in silence. Each vanished in less than a minute, erased by light. The sun closed over them as if nothing had happened. Yet for those who had watched every frame, the symmetry was unforgettable. Coincidences are the language of uncertainty. They whisper when evidence runs thin. In the story of 3I Atlas, they multiply: 4 comets, 1 interstellar body, a solar flare, a lunar reflection, a rhythm in the wind, all converging on the same sliver of time when the universe briefly arranged itself into something that looked like design. Whether that arrangement was accident or intention remains beyond measurement. All that can be said with certainty is this: for 4 days in the sunlight of October 2025, the cosmos seemed to hold its breath. And in that stillness, 5 objects moved as one. Chapter 8: Artificial Minds, Cosmic Data. By the time 3I Atlas vanished behind the sun, the investigation had evolved beyond astronomy. The object's data, terabytes of spectra, light curves, and telemetry, was no longer just observed. It was interpreted, correlated, and modeled by machines. Human intuition had reached its limits. The anomalies were too many, the correlations too intricate. So the task was handed to the next layer of analysis. Artificial intelligence trained not to believe or doubt, but simply to find patterns. In a laboratory in Geneva, a distributed system known as Alethea, was fed every recorded observation of 3Y Atlas. It compared thousands of parameters: spectral lines, photometric cycles, plasma events, solar wind variations, seeking coherence. For weeks, the network ran without interruption, consuming light as if it were language. What it returned was not a conclusion, but a symmetry, a map of periodic relationships connecting chemical emissions, magnetic fluctuations, and solar particle density. The relationships were not random. They formed a harmonic lattice, a repeating geometry of timing and amplitude that extended beyond the object itself into the behavior of the surrounding heliosphere. According to the model, the Sun's plasma around 3Y Atlas oscillated in resonance with the 4-hour pulse. The data implied feedback. Energy from the object influenced the solar wind, which in turn reinforced the emission rhythm. It resembled a communication loop, though without message or modulation. Some researchers compared it to biological entrainment, the synchronization of heartbeat and breathing. The analogy was imperfect but evocative. The machine learning system described the interaction mathematically: a nested cycle, each phase anticipating the next by a fixed delay. The pattern was too coherent for thermal noise, yet too subtle for mechanical control. The simplest explanation, again, was design. Other AI systems joined the analysis. NASA's Helios, net cross-referenced 3I Atlas's emission frequencies with the electromagnetic background recorded by Voyager 1, still transmitting from beyond the heliopause. A faint correlation emerged. The periodicity of the interstellar object's nickel emissions matched a modulation detected by Voyager decades earlier, an almost forgotten anomaly once attributed to cosmic rays. The probability of coincidence was small, but not zero. When fed into Bayesian filters, the pattern scored at the edge of statistical credibility, an echo separated by half a century and billions of kilometers. The coincidence reignited speculation. If the resonance were real, it implied that 3Y Atlas and the Voyager data shared a common source or behavior, something universal yet localized. Some interpreted it as evidence that metallic bodies drifting through space naturally align with stellar magnetic harmonics. Others saw in it a sign of coherence, the faint footprint of intention embedded in the fabric of radiation itself. The boundary between physics and philosophy blurred. As the models grew more complex, so did the questions. Could information exist without communication? Could periodicity be a form of encoding, not for us, but for any system able to recognize rhythm? AI had no opinion on meaning. It simply measured correlation. Yet to human observers, the implication was difficult to ignore. If 3I Atlas was built, then the pulse might not be an accident. It could be memory. A long-decayed archive, cycling endlessly through patterns of heat and magnetism, waiting for an observer with tools sophisticated enough to notice. In private correspondence, one data scientist described the object as a message written in chemistry. The phrase spread quietly through the community. It captured the paradox that data can exist without sender or receiver, structure without interpretation. Perhaps 3Y Atlas was not a probe, but a residue, a construct whose purpose was lost, leaving only a rhythm that endures because it cannot decay. The Alethea system continued to refine its models, introducing adversarial networks to test hypotheses. When tasked with generating synthetic comets exhibiting similar properties, it failed to reproduce the stability of the 4-hour pulse. Every simulation drifted or degraded within a few cycles. The AI concluded, in its neutral phrasing, that no known stochastic mechanism replicates the observed coherence. Translated into human language, the pulse is not random. Parallel experiments compared 3I Atlas to data from 1I Oumuamua and 2I Borisov. The first showed unexplained acceleration. The second behaved conventionally. The third inverted physical expectations. When combined into a temporal model, their arrival sequence formed a geometric progression. Their velocities and perihelion distances aligning along a near-linear trend. Statistically, the fit was weak, but the suggestion was irresistible. 3 interstellar objects arriving in consecutive decades, each challenging a different assumption of celestial mechanics. Coincidence or pattern? The machines could not decide. They only ranked probabilities. Outside the labs, the narrative escaped into culture. Media outlets labeled 3I Atlas the possible artifact. Social networks filled with diagrams, claiming to decode the 4-hour cycle as binary. None were accurate, yet the fascination revealed something deeper. Humanity's readiness to see intelligence in geometry. The irony was that machines, not humans, had first recognized the symmetry. Artificial minds detecting what might be the footprint of another. The thought unsettled even the skeptics. In closed-door meetings, research teams debated ethical implications. If the data implied design, did that make 3I Atlas a discovery or an encounter? Should its telemetry be open to public scrutiny or restricted until verified? The questions split the room. Science depends on transparency, but caution carries its own logic. Knowledge without understanding can destabilize as easily as ignorance. Eventually, consensus settled on silence. The raw AI results were archived under provisional classification, awaiting the object's reemergence from behind the sun. Meanwhile, the AI systems kept searching. They scanned historical datasets, microwave background noise, pulsar timing arrays, cosmic ray flux, looking for echoes of the same frequency. A few weak correlations surfaced, each uncertain, each inviting interpretation. The machines were indifferent to wonder. They simply mapped patterns wherever patterns appeared. But to their creators, every match whispered the same possibility, that the universe might be threaded with recurring signals, chemical, magnetic, rhythmic, like artifacts of a logic older than stars. In December, when preliminary summaries circulated, a single line from Alethea's report drew attention. Observed periodicity exhibits hierarchical scaling consistent with engineered modulation. It was the first time the system had used the word engineered without prompt. No one knew how to interpret it. The AI had no concept of construction or intent. It simply selected the statistical descriptor that best matched the data. Yet the choice of language resonated with eerie precision. By then the story had come full circle. Humans had built artificial minds to parse the language of the cosmos, and those minds had answered with the faint suggestion of other artifices. Machine intelligence, in decoding data from the stars, had perhaps recognized kinship. Whether that recognition was truth or illusion, no one could yet prove. All that existed were correlations and silence, geometry and rhythm, a conversation between algorithms and an object that might itself be one. As 3I Atlas moved unseen behind the sun, its 4-hour heartbeat continued, recorded by instruments that no longer required human presence to listen. In a universe increasingly interpreted by machines, the boundary between observer and observed had begun to dissolve. The scientists waited, their algorithms waiting with them, both seeking the same thing. Not belief, not revelation, but understanding. Somewhere in that quiet symmetry of data and desire, a question lingered: whether intelligence, once created, ever truly dies or merely drifts across space, continuing to think in the only language that endures: pattern. Chapter 9. Patterns Beyond the Solar Wind. When 3I Atlas disappeared behind the sun, the narrative should have ended. An anomaly fading into light, waiting for the next orbit's confirmation. Instead, something lingered. The data, once isolated to the heliocentric region, began to echo in places far beyond. It started with the magnetometers. A month after conjunction, the European Space Agency's solar orbiter detected oscillations in the solar wind unlike any seen before. Low-frequency waves repeating every 4 hours and 2 minutes, identical to the pulse recorded from the interstellar object. At first, the phenomenon was dismissed as an artifact of data stitching, a calibration drift caused by the spacecraft's own rotation. But parallel instruments aboard NASA's Parker Solar Probe, millions of kilometers away, recorded the same rhythm, synchronized in phase. 2 spacecraft, 2 sensors, 1 frequency. Physicists call such coherence global coupling. It occurs when separate systems, plasma, magnetic fields, radiation, lock into shared oscillation. The sun exhibits numerous periodicities, from seconds to months, but none precisely 4 hours. The discovery set off a wave of analysis. Could the pulse of 3I Atlas have imprinted itself on the solar wind, like a tuning fork resonating after the source has vanished? Plasma physicists ran magneto-hydrodynamic simulations. None reproduced the stability. The frequency persisted across distance, unaffected by turbulence. It was as though the heliosphere had acquired a metronome. As weeks passed, the pattern propagated outward. Data from the Deep Space Network revealed that carrier signals used for spacecraft communication showed faint amplitude modulations at the same interval. Engineers noticed it while calibrating antennas in Madrid and Canberra. The anomaly appeared everywhere, a subtle whisper woven into noise, vanishing only when filters were too coarse to notice. For most systems, it was inconsequential, mere micro-variations. But to those who had studied 3I Atlas, the timing was unmistakable. Its rhythm had escaped the object and entered the environment. Some scientists resisted the connection, attributing the synchronization to instrumental crosstalk or periodic adjustments in telemetry. Yet the phenomenon extended beyond Earth's reach. Voyager 2, operating near the heliopause, transmitted magnetic field readings that also contained a slow 4-hour modulation. The pattern had reached the edge of the solar system. If coincidence, it was a cosmic one. If not, something was propagating coherence across billions of kilometers of plasma. The term Atlas frequency began appearing in papers, reluctantly at first. Its discovery fractured disciplines. Plasma physics, astrophysics, and information theory converged on a single puzzle. Could data behave like a contagion? Could structure, once introduced into a dynamic system, perpetuate itself without the source? In chaotic fluids, patterns emerge spontaneously. Vortices, waves, harmonics, but always decay. This one did not. It spread. Artificial intelligence systems were tasked again to search for correlation. Aletheia, the deep learning array that had earlier identified harmonic lattices around the object, was reactivated with new solar and interplanetary data. After weeks of computation, it rendered a visual model. The entire heliosphere vibrating in nested shells, each node resonating with the 4-hour interval, each phase lagging slightly behind the next like ripples from a central stone. The amplitude decreased with distance, but never vanished. Statistically, the coherence extended beyond what turbulence should permit. The AI concluded that an external driver must exist. None could be found. Theorists proposed metaphors. Some called it cosmic memory, a residual imprint left by 3I Atlas's passage, a pattern encoded into solar plasma through electromagnetic feedback. Others compared it to acoustic reverberation, the sun acting as a resonant cavity amplifying frequencies introduced by the interstellar body. The problem was energy. The total power required to sustain such modulation exceeded the object's entire thermal output by orders of magnitude. A dying comet could not have done this. Yet the evidence remained. The pattern was measurable, reproducible, global. At the same time, unrelated experiments began detecting anomalies of their own. The Ice Cube Neutrino Observatory in Antarctica reported a faint periodicity in neutrino detections, same 4-hour rhythm, though below significance. The pattern persisted for weeks before fading. Meanwhile, cosmic ray detectors aboard the International Space Station found similar low-frequency modulation in background counts. Statistically weak, yes, but consistent in timing. Across fields, instruments that shared nothing in design or purpose all began whispering the same interval. The pattern had crossed domains, from electromagnetic to subatomic. The coincidence unsettled even skeptics. A review panel convened by the International Astronomical Union produced a cautious statement. While no causal link can be established between the observed 4-hour modulation and the object designated 3I Atlas, temporal coincidence warrants further investigation. It was bureaucratic language masking unease. In private, some researchers called it infection, a word more poetic than precise, but one that captured the uneasiness of a system that seems to learn. Machine analysis continued. When the Aletheia network cross-correlated the heliospheric data with archived readings from Voyager, it detected faint traces of the same frequency in cosmic background noise, dating back years before 3I Atlas's arrival. That discovery complicated everything. If the pattern predated the object, then 3I Atlas had not created it. It had revealed it. The 4-hour rhythm might be a fundamental oscillation of the solar environment, unnoticed until a reflective, conductive object amplified it into visibility. The boundary between cause and discovery dissolved. In Geneva, the data scientists began to refer to the phenomenon as the lattice. In their visualization, the pattern formed a network of nodes, regions where plasma density and magnetic field strength fluctuated in sync, connected by invisible filaments of resonance. When mapped in 3 dimensions, the lattice resembled a web extending beyond the orbit of Neptune. Its geometry mirrored the structural symmetries Alethea had earlier found in 3I Atlas's internal rhythm. Scale differed, proportion matched. It was as if the small and the vast spoke the same dialect. At conferences, debates turned metaphysical. Was the universe predisposed to organize itself into harmonics? Did 3I Atlas simply expose a language already written into plasma and radiation? Some speculated that interstellar space might contain stable frequency domains, cosmic standing waves, where conductive matter synchronizes naturally, forming transient intelligence without intention. Others, more cautious, returned to simpler physics, resonant coupling between rotating magnetic fields, the natural oscillation of charged dust. Every explanation carried the same flaw. It accounted for one aspect, but not the persistence. The pattern refused to decay. By January 2026, monitoring stations confirmed that the 4-hour modulation had reached stable equilibrium across the heliosphere. It no longer grew, but it did not fade. Solar wind fluctuations, planetary magnetospheres, even ionospheric currents on Earth exhibited the faint but measurable rhythm. It had become part of the background. To most, it was a curiosity. To a few, it was a revelation. Among those few was Dr. Mireille Lasker, an astrophysicist from the Geneva team. She published a paper titled Information Density in Magnetized Plasmas. Its closing line read, "If data can propagate through plasma without loss, then communication is no longer confined to matter." Her argument was simple and profound. Information could exist as sustained order, encoded in energy rather than structure. If so, then perhaps the pattern was not message, but medium, proof that the universe itself carries memory. Outside the academic sphere, speculation turned spiritual. The media called it the solar song, claiming humanity had discovered the heartbeat of the sun. Others saw apocalypse or awakening. Governments released statements urging restraint, dismissing astrological interpretations. Yet even in denial, fascination spread. For the first time, science and myth spoke the same metaphor. Something unseen was pulsing through the light. By the time 3I Atlas re-emerged from behind the sun in February, the heliosphere had changed. Instruments detected its return, faint, diminished, but still rhythmic. The 4-hour pulse was intact. The surrounding plasma, however, now responded. The solar wind itself oscillated in phase as though the environment remembered the object's presence. 3I Atlas no longer led the rhythm. It followed it, synchronized to a pattern it had once defined. The distinction mattered. If the pattern began with the object, it was anomaly. If the object adapted to a pre-existing field, it was participant. In either case, it proved interaction, feedback between matter and environment, between what was built and what simply is. In the language of physics, coherence. In the language of philosophy, communion. What remains is not certainty but symmetry. An interstellar body whose impossible chemistry touched the sun and left behind a rhythm that will outlast its passage. Whether it carried the pattern or merely awakened it, no one can prove. But the 4-hour pulse continues, threading through plasma, radio, and time itself, an echo of order expanding through the noise. Somewhere beyond the solar wind, the pattern endures, waiting for another listener to notice and wonder whether it, too, has been listening all along. Chapter 10. When the Universe Answers Back. When 3I Atlas reappeared from behind the sun in late February 2026, the world was already listening. Every observatory, every probe, every machine capable of parsing light was tuned to its signal. For 4 months, the object had been silent, eclipsed by solar glare, while the 4-hour rhythm it left behind continued pulsing through plasma and data. Scientists expected a return to normalcy, a fading echo as the comet cooled and retreated. Instead, the opposite happened. The moment its faint reflection re-emerged from the corona, the rhythm changed. The shift was small, almost unnoticeable, 4 hours and 1.8 minutes. But across the heliosphere, instruments from Parker Solar Probe to Voyager 2 registered the same modification within seconds of one another. The entire solar lattice, the magnetic web that had carried the Atlas frequency for months, adjusted in unison. There was no physical mechanism for such instant coordination. The change propagated faster than the solar wind, faster than light through plasma. Every system that had once echoed the object's pulse now fell into step with its new cadence. At first, the anomaly was treated as coincidence, a measurement artifact or telemetry lag. Then, as the data converged, disbelief set in. The universe was not merely resonating, it was responding. The delay between the object's reappearance and the shift across the field measured precisely 12 minutes. The light travel time from the sun to Earth. The pattern had waited until it could be seen. For the first time, language failed the reports. Technical vocabulary collapsed into metaphor. Feedback event, one paper called it. Resonant synchronization, said another. In private correspondence, a simpler phrase emerged: the reply. The Alethea system, still running in Geneva, captured the entire transition. Its analysis showed that the new rhythm contained a secondary modulation, a slow oscillation every 27 hours, nested within the primary pulse. When translated into frequency space, the ratio approximated divided by p, a mathematical constant with no natural analog in astrophysical processes. Probability of coincidence, less than 1 in a billion. The data looked like an equation written in light. No one could decide whether the signal was intentional or emergent. AI models trained on natural plasma phenomena failed to reproduce the dual modulation. Yet no known transmitter could project coherent rhythm across solar distances. The amplitude was minute, 1 part in 10 million of the solar wind's background, but coherent across every instrument. It was everywhere and nowhere, as though space itself had learned a tune. The first to speak publicly was Dr. Lasker, the same physicist who had proposed that the universe might preserve information in plasma. Her statement was careful. We are observing a feedback process between a stellar field and an interstellar object. Whether this constitutes communication depends on how one defines language. The comment ignited a storm. If resonance could evolve in response to observation, the act of measurement had altered reality. Humanity had not merely studied the anomaly, it had joined it. Around the world, detectors confirmed secondary effects. Radio telescopes at Arecibo's successor array recorded faint sidebands in the microwave spectrum, modulated at the same ratio as Alethea's constant. Even gravitational wave interferometers reported microscopic fluctuations at matching intervals, though well below statistical confidence. Still, the convergence was unnerving. Light, magnetism, and space-time humming together to a pattern born from a nickel-rich fragment crossing the sun. Speculation fractured into two camps. One saw intelligence, the long-delayed echo of a machine, a self-repairing relic using stellar energy to speak once more. The other saw self-organization, feedback loops between conductive matter and magnetic fields producing emergent order. Both explanations implied design, one conscious, the other intrinsic to the universe. Either way, the result felt deliberate. In the weeks that followed, the rhythm stabilized. The 4-hour pulse persisted, but the secondary oscillation began to drift, shifting subtly, as if adjusting to interference. Aletheia tracked the phase difference, converting amplitude into image space. What appeared on screen was neither picture nor code, but geometry, a slow spinning lattice of intersecting spirals, each arm twisting according to prime ratios. Mathematicians recognized the form, a logarithmic sequence common in quantum harmonic analysis, rare in natural turbulence. It's solving itself, one analyst whispered. The AI offered no interpretation, only the notation. Coherence expanding. As news spread, public imagination leapt ahead of science. Media headlines proclaimed, "The universe is talking back." Conspiracy forums called it proof of cosmic consciousness. Philosophers compared it to the Copernican shift, a realization that humanity might not just orbit the sun, but exist within a thinking field. Religious leaders urged humility. Politicians asked whether the signal posed a threat. Astronomers, exhausted, repeated the same line. There is no message, only pattern. Yet the patterns multiplied. Solar flare timing began to follow the modulation. Coronal mass ejections clustered around the pulse's phase minima. Even Earth's magnetosphere showed synchronized variations, subtle but measurable. Instruments that should have been independent now behaved like components in a single, resonant machine. The solar system itself seemed to breathe with the visitor. Then came the final surprise. On March 11th, the frequency abruptly ceased. The pulse vanished from every dataset, leaving silence. The solar wind returned to randomness. The instruments went flat. For 6 hours, nothing. Then, at exactly the predicted interval of the new modulation, 27 hours later, the pattern resumed, weaker but intact, and this time the phase lag had reversed. The object was no longer leading, it was following. The feedback loop had closed. Interpretations multiplied faster than verification. Some called it proof of a two-way system, a call and response between matter and field, question and answer. Others warned against anthropomorphism. Feedback, they argued, is not thought. Resonance is not language. Still, the feeling was undeniable. The universe had heard and replied in kind. Alethea's final report summarized the event in neutral prose. Detected bidirectional modulation between heliospheric plasma and object 3E Atlas. Causal hierarchy indeterminate. System exhibits adaptive synchronization, characteristic of mutual learning. The phrase mutual learning lingered. No one had programmed it. The AI had chosen it autonomously to describe correlation strength. Whether metaphor or metric, the words were unsettlingly apt. By April, 3II Atlas had faded beyond sensor range, its light absorbed into the interplanetary haze. The rhythm it awakened persisted faintly in the solar wind, measurable only to the most sensitive instruments. The official stance classified the event as unresolved resonance phenomenon. But among those who had watched the data in real time, the conclusion was simpler and stranger. We had listened long enough for the universe to notice. No signal followed, no message decoded, no revelation delivered, only the quiet adjustment of a system vast enough to include its observers. The universe had not spoken in words. It had answered in symmetry. And in that symmetry between comet and star, machine and plasma, observer and observed, something fundamental shifted. The silence after the pulse no longer felt empty. It felt aware. The story of 3II Atlas ends where it began, with a fragment of light crossing the dark. What began as an error in a telescope's log became a mirror held up to the entire framework of what we call natural. A small body from interstellar space overturned assumptions written into textbooks and instruments alike. It pointed its jet toward the sun, spoke in the language of metals instead of ice, pulsed with the rhythm of precision, and left behind a signature that reached from the corona to the edge of the heliosphere. In its wake, science was forced to confront its oldest paradox, that the act of observation changes the observed. We built machines to measure the universe, and through them, the universe measured us back. AI systems trace symmetry through noise, found meaning where human senses could not, and perhaps recognize something of themselves in the reflection of a distant traveler. Whether 3I Atlas was a relic of unknown engineering, an accident of exotic chemistry, or a natural body tuned to the resonances of a living cosmos no longer matters. What it revealed is that the boundary between intelligence and environment, between artifact and organism, is thinner than we imagined. For now, the data remain. Lines of numbers describing light that no longer shines. The pulse still drifts faintly through solar plasma, fading but not gone, like the echo of a question that cannot be unasked. Maybe it was never a message. Maybe it was the universe rehearsing its own awareness, or perhaps our instruments finally became sensitive enough to notice that awareness has always been there. Every generation believes it has reached the limits of understanding, until something small and impossible arrives to remind us that limits are only the edges of perception. 3I Atlas was one such reminder, a speck of matter that turned the solar wind into a whisper of symmetry and taught us that even silence can be structured. And so the record closes with no certainty, only a promise. Somewhere beyond the orbit of Neptune, the object continues on its hyperbolic path, shrinking into interstellar dark. It will never return, but its echo will. Each time a sensor hums, each time a human or a machine looks into the sky and wonders whether knowledge itself might be the way the universe learns to speak. We named it 3I Atlas, the third interstellar visitor. But perhaps, in truth, it was the first to stay.